Hi, this is a Lab 7 tutorial video. In this lab, you'll be processing, cleaning, and analyzing your data. In past tutorials, we've gone over descriptive and inferential statistics in R. Today, we'll be focusing on downloading your data from Google Forms or Qualtrics, processing and cleaning your data in R so that you can run your descriptive and inferential statistics. Let's begin. First, we'll look at how to download data from Google Forms. If we go back to forms.google.com, I'm going to show you guys an RSVP form that I did for a game night that I held at my house. If you go to responses and you go to this view responses in sheets tab, here I have an Excel file with the names of each of those questions as well as each of those responses. I can go to file, download, and I can download it as an XLS or as a CSV. I personally prefer CSV files, but you might be more familiar with XLX, and that is totally fine. Next, let's look at Qualtrics. So if we go back to qualtrics.colorado.edu, we'll log in. And here I have a demo survey that we'll use as as the basis of this tutorial. So in this demo survey, I have a sample informed consent. I have 3 questions that are Likert scales, as well as a memory question that I've scored. So a couple things that I've done on the survey, and you can do this after you collect data as well, that can help with data analysis. So here what I've done is I've recoded these values from 7 being strongly agree to 1 being strongly disagree. If you notice, this first question and the second question are opposites of each other. So how much fun are you having today versus do you feel life is hard? So I reverse coded the second question. So strongly agree is now 1 and strongly disagree is 7. I'd highly recommend reverse coding things in Qualtrics because that way you don't have to do anything in R when you combine these questions together to make a scale. The other thing I'd like to have you guys notice is that I have renamed these variables as something that I can understand in R. I'd highly recommend keeping everything lowercase. I'd recommend not having any spaces at all. So here I've shortened this to fun. I've named this as hard and then named this as enjoy. This is much easier than having a question be Q8, where you don't actually know what Q8 means. You don't know if it's part of a survey block or anything like that. So I'd highly recommend changing something like Q8 to memory test. Okay. Here there's no spaces, so if I want to make a space, I can do an underscore or something like that. That'll greatly help you in R. So let's presume that you have collected all of your data and you now want to download your data and process it in R. If we go to the data analysis tab up at the top, here we see we have 10 recorded responses and 1 response in progress. So all we need to do here is actually just hit export data. And here I'd like to show you 2 things. So you'll automatically be exporting as a CSV file, and you'll likely want to download all fields. Now the question is whether you need to use your numeric values or choice tests. Let's imagine that we are asking about people's gender identity. So we might ask them, do you identify as a male, female, non-binary, or something else? If we use numeric values, those in the data file will be represented as numbers, such as 1, 2, 3, and 4. However, if we use choice text, Likert scales will be represented by words like strongly agree and strongly disagree. So each of these formats have different uses, and sometimes it's beneficial to download both. First, I'd recommend that you download numeric values, as any Likert scales that you'll be working with will be easier to work with in numeric values. Click download. And if you get the option to open it in Excel, I would highly recommend that you open any data file that you download first. So here is the data file that shows up in Qualtrics. The first row is the row of questions that you have already set up. Here you have column S is fun, column T is hard, column U is enjoy, column V is memory. At the end, you also have a score. So I scored the memory test and asked people to mark all the words that they remembered, and Qualtrics automatically calculated a score for me. The second row here and the third row here have additional information about your questions. For example, the second row has the exact text of each of those questions, and the third row has your import IDs. For our purposes, the second and third rows are not useful to us. So if we select both rows and right click on a Mac or a PC and click delete, we can delete both of those rows. Now, the other thing I want to point out to you is this distribution channel. So you may have done a bunch of survey previews when testing out your survey. That's not real data, and that's not data that you actually want to analyze because it's not data from your participants, it's data from you guys. So this is also data that we might also want to disclude, and doing in Excel might be helpful. So here I have preview, and I'm going to delete. So this is the other way to delete rows. I'm going to hit the down arrow on the delete button and click delete sheet rows. So now I have my data file. I have 4 responses. Here is the bulk of that response information. So I'm going to click File, Save As, and save this as something that will make sense to me to download, to import into R. Okay, I'm going to have a file format as CSV. We're going to save this. Next, we've opened up RStudio. So here I have a console, I have my environment. So the first thing I'm always going to do is go to New File, R script, and I'm going to save this R script as well. So if we go to File, Save As, and here I'm going to put this in my Downloads folder. I'm going to call this Lab Test, and it will automatically save it as a .r file. So if we go look at it, it says labtest.r, and that is the .r file that I'd like you guys to upload to Canvas. So I'm going to show you 2 different ways to import the data set. The first is going to be the reproducible method or the script method of doing things. So I'm going to give it a name. I like to give my data sets the name D because it's easier for me to remember the word data. So I'm going to do read.csv. The computer will use a file path to look for that. So I'm going to use this syntax. And if you have a Mac, you can also follow the syntax. And if I load that in, I have my data file with all of my questions. Okay. The other way we can do this is also through the point and click method. So here I can click on import dataset. If we're importing a CSV file, you'll want to click from text. If you're importing an XLX file, then you'll click from Excel. Mine is a CSV file, so I'm going to click from text. And then I'm going to go find it. Here is that lab test. And I'd highly recommend reading through because you can notice here down in the data frame, it shows you a preview of what's going on. The top line says V1, V2, V3, V4. That's not how we want this data set to work. We want it to know that we have a heading. So we're going to tell it has a heading, change that to yes. And now the heading is in bold. And we can change the name here as well. So I'm going to call this D1. So now I have D and D1 both available to me, 4 observations and 23 variables. One of the things you might need to do is to process or clean your data. For example, if you have a bunch of Likert scale questions that need to be combined, such as fun, hard, and enjoy, we might need to make a new variable to combine those items. So to make a new variable, we want to actually have that variable sit within the data frame. So to do that, we need to use the $sign method. So we do $. We're going to call this a scale. This name right here is something that I made up. You can refer to it as anything you'd like. And then here, I want to have an average of these 3 items. So I'm going to do $D fun plus $D hard plus $D enjoy. Now to make an average, all I'm going to do is encase all this in parentheses and divide by 3. So I hit enter and it shows up in my console. And let's go over to D. And you'll notice at the end it says a scale. So we've created this variable within this data frame. Now we can calculate a mean. And we see the mean is 5.25. If you would like to use the attach method, I'd highly recommend using the attach method after you've created all your variables. If you attach your data frame before you create your variables, you'll have to reattach it after again. You'll have to rerun the attach command. If you have a scale, just a reminder, you're going to need to calculate Cronbach's alpha. To calculate Cronbach's alpha, we need to figure out how each of the answers on each of those questions correlate with one another. So we need to subset the data and essentially create a new data frame with just those questions and then run alpha on just those questions. So we're going to create a new data frame called dsub. And this is going to be called subsetting the data. The way we do this is we tell the computer what is the data frame we want to start with, what are the parameters you want to subset the data. So here the format is rows, comma, columns. So we only want to keep 3 columns, but we want to keep all the rows. So if we go back to our data frame and we hover on each of these columns, we see that fun is column 19 and enjoy is column 21. So over here, we'd put 19:21, 19 through 21. And now we have dsub, which has 4 observations of 3 variables. Then we can load this PSYC library package. And run alpha of dsub. So here we see that our raw alpha is negative 0.17. And if we look below, we can see that the reliability if an item is dropped. So here we can see that if hard is dropped, the reliability will shoot up to 0.84. So clearly that middle question of hard is not working out as we intended. In this particular scenario, I constructed the data set to have this issue. You likely won't have a similar issue, but if you do, I'm happy to talk about it in class. So now let's imagine we want to run a correlation on our scale variable and our score variable. So we could run a core.test. Of our scale and our SC0. And we can see in our console that there is our correlation estimate is 0.547, but this correlation is not significant. One of the benefits of using a score is that you don't have to do much processing on it. So here are memory tests, people responding to what questions they remembered, what words they remembered in a fictional memory recall test. Our score automatically calculated how many questions they remembered. So here they have, they remembered 3 words, the second person remembered 1 word, and each of the last 2 people remembered 2 words. We now do not have to code each of these questions to see if they got each answer correctly, because the score already does that. So we can jump right into getting a correlation or getting our t-test or getting our descriptive statistics or whatever you need to do.